Hey guys, today we're talking about finding maximum or minimum values of a function. And what I mean by that is if I were to graph a function, a quadratic function, and it looked like this. Well, this is the top of the function right here. Well, that would be the maximum that function can go. All right. But if I had one that looked, let's say like this, right there, that would be the minimum that function could go. All right. Notice that the maximum is at the top of a negative function. If I were to graph this, it would be negative. While the minimum is the bottom of a positive function. Okay. So remember that if the function is negative, it's going to have a maximum. And if it is positive, it is going to have a minimum. So let's say we have y equals 3 times x minus 5 times x minus 7. And I want to know if this has a maximum or a minimum. Well, I look to the beginning here and I see that my leading coefficient is positive. So since it's positive, I know it is going to have a minimum. So I'm looking for a minimum here. So the way I find the minimum is, if you'll remember, if you have a function in intercept form. So this is an intercept form. What I'll need to find is where the vertex is. The vertex, the y coordinate of the vertex, will give me my maximum or minimum. In this case, the minimum. So I have to find the y coordinate of the vertex. So if you'll remember that I need to find first the x, and that is p plus q divided by 2. Well, here I have p, and my p is 5, plus my q, which is 7, divided by 2. 5 plus 7 equals 12, divided by 2 is equal to 6. So the x coordinate of my vertex is going to be 6. So now what I need to do is I need to take that 6 and I need to plug it back into the original function. So y is equal to 3 times 6 minus 5 times 6 minus 7. Well, that'll be 3 times 1 times negative 1. Well, 3 times 1 is 3, times negative 1 is negative 3. So my minimum equals negative 3. And that's how you find a minimum value in a function that is in intercept form. Now let's say I have y equals negative 2 times x plus 4 and x plus 6. So we'll notice that this is also in intercept form. So I will first want to know, is there going to be a maximum or a minimum? Well, I look right here and I see that my leading coefficient is negative. So if it is negative, that's how I know it is a maximum. All right, so we're looking for the maximum. So I need to find the y coordinate of the vertex. So to find that, I will do x equals p plus q divided by 2. Well, if you'll remember, in intercept form, this should be x minus p and x minus q. That means that p is actually -4 and q is actually -6. So I will do -4 minus 6 divided by 2. Well, -4 minus 6 is -10 divided by 2 is -5. So my x coordinate of my vertex is -5. So I'll take that -5 and I will plug it back into the original function. So y is equal to -2 times -5 plus 4 times -5 plus 6. And that's going to be -2 times -1 times 1. -2 times -1 is 2. 2 times 1 is 2. So the y coordinate of the vertex is 2. So my maximum is 2. So let's say we have a function that is in vertex form. Well, I want to know, is this going to have a maximum or a minimum? Well, I look and see that it is negative. And since it is negative, I know that it will have a maximum. So we're looking for the maximum of this function. Well, just like in the other problems where we were dealing with intercept form, it will be the y coordinate of the vertex. Well, if you know anything about vertex form, you'll know that the vertex is at HK, and vertex form, that's y equals a times x minus h squared plus k. So that's my algebraic model. Now you'll notice that I'm looking for the y coordinate of the vertex. So I'm looking for k. Well, k is right here. So at the end, that means that my maximum is 7. So on this one, you would just write maximum equals 7. And that's how you find a maximum of a quadratic function written in vertex form. So let's say we have a function written in vertex form, and I am looking for a maximum or a minimum. So I'll look here and see that my leading coefficient is positive. Therefore, it will have a minimum. So I'm looking for a minimum. And if you'll remember from the last problem, I'm looking for the k. So what is k here? Y equals a times x minus h squared plus k. So the k here is actually -3. So my minimum is -3. And that's how you find maximum or minimum values of functions either in vertex form or intercept form.